In this episode, we take the layered networking model you just built and zoom in on two core ideas that drive how data actually finds its way across networks: IP addressing and routing. If you understand how devices are identified and how routers choose paths, you can reason about many common security controls and threats without getting overwhelmed. Internet Protocol, IP, addressing is how devices are logically identified across networks, and routing is how data is forwarded from one network to another. These ideas are foundational not only for networking, but for understanding segmentation, exposure, and attack paths. The GISF exam does not expect deep mathematical subnetting skills, but it does expect you to understand what an IP address represents and how routing decisions affect security boundaries. Our goal is to make addressing and routing feel like a clear map rather than a technical maze. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start with the idea of an IP address as a logical identifier. An IP address identifies a device on a network in a way that allows routers to forward traffic toward it. Unlike hardware addresses that are tied to a specific network interface, IP addresses are used across multiple networks and are structured to support routing. In the most common version used today, an IPv4 address is written as 4 numbers separated by periods. Each number represents part of the overall address. What matters conceptually is that an IP address has 2 logical parts: a network portion and a host portion. The network portion identifies which network the device belongs to, and the host portion identifies the specific device within that network. This structure allows routers to make decisions based on network membership rather than memorizing every individual device. Now think about why separating network and host portions matters. Routers are responsible for forwarding packets between networks. When a packet arrives, the router examines the destination IP address and looks at its routing table, which is a list of known network paths. The router does not need to know the exact location of every host. It needs to know how to reach the destination network. Once the packet reaches the correct network, local mechanisms deliver it to the specific host. This layered routing approach makes global communication scalable. From a security standpoint, understanding that routing decisions are based on network prefixes helps you see how segmentation works. When you restrict communication between networks, you are influencing routing paths and limiting which systems can talk to each other. Let's introduce the idea of private and public IP addresses, because this distinction appears frequently in security discussions. Public IP addresses are routable across the global internet and can be reached from outside an organization. Private IP addresses are reserved for internal networks and are not directly routable on the public internet. Organizations use private address ranges internally and often rely on mechanisms like network address translation to allow internal devices to access external resources. The important concept is that devices with public IP addresses are generally more exposed to external threats than devices using private addresses behind a gateway. On the exam, if a scenario describes an internet-facing server, think about public addressing and higher exposure risk. Network address translation, often abbreviated as NAT, is a technique that allows multiple internal devices with private IP addresses to share a single public IP address when communicating externally. The gateway device rewrites source or destination address information as traffic passes through it. While NAT can provide a level of obscurity and limit direct inbound access, it is not a security control by itself in the same way that a firewall is. It does, however, influence how traffic flows and how internal addresses are exposed. In exam scenarios, if you see references to internal addresses being hidden from external networks, NAT may be part of the explanation. The key is understanding its role in translating addresses rather than assuming it guarantees security. Now let's focus on routing paths and how routers decide where to send traffic. A router maintains a routing table that contains entries mapping destination networks to next hop paths. When a packet arrives, the router compares the destination IP address against its routing table entries. It chooses the most specific match and forwards the packet accordingly. If no specific match exists, a default route may be used to send traffic toward a general upstream network. This process happens repeatedly across multiple routers until the packet reaches its destination network. From a security perspective, routing determines which paths traffic can take and therefore which boundaries it crosses. If routing is misconfigured, traffic may flow in unintended ways, increasing risk. Segmentation is a key security concept that depends heavily on IP addressing and routing. Segmentation means dividing a larger network into smaller networks and controlling communication between them. Each segment has its own network address range, and routers or firewalls enforce rules about which segments can communicate. For example, a sensitive database network may be segmented from a user workstation network, with strict controls limiting access. This reduces the likelihood that a compromise in one segment leads directly to compromise in another. When exam questions discuss limiting lateral movement or protecting critical systems, segmentation is often the correct strategy. Understanding that segmentation operates at the network and routing level helps you place this control correctly. Subnets are closely related to segmentation. A subnet is a subdivision of a larger IP network into smaller logical networks. Subnetting allows administrators to organize devices by function, department, or security level. Even if you are not calculating subnet masks for this exam, you should understand that subnetting changes the network portion of IP addresses to create separate routing domains. Each subnet typically requires routing to communicate with others. This creates natural points where access controls can be enforced. When you see references to isolating systems into different network ranges, that is often implemented through subnetting and routing configuration. Let's connect routing to attack paths. An attack path is the sequence of steps an attacker takes to move from an initial foothold to a valuable target. If routing allows unrestricted communication between networks, an attacker who compromises one system may be able to reach many others. If routing is tightly controlled and segmentation is enforced, the attacker's movement is restricted. This is why understanding IP addressing and routing is critical for security design. Controls like access control lists on routers or firewalls depend on knowing source and destination IP addresses and network ranges. On the exam, if asked how to reduce the spread of an attack within a network, answers involving segmentation and restricted routing are often strong. Another important idea is that IP addressing does not guarantee identity. An IP address tells you where traffic is coming from or going to at the network level, but it does not by itself prove who is behind that address. Attackers can spoof or forge source IP addresses in certain scenarios, particularly in connectionless communication. This is why higher-layer authentication mechanisms are necessary. Recognizing the limits of IP addressing helps you avoid overestimating its security value. If an exam question implies that allowing traffic based solely on IP address ensures identity, that answer may be incomplete. Identity verification typically requires additional controls beyond network addressing. You should also understand that routing decisions can affect availability. If routing tables are incorrect or if a critical route is unavailable, traffic may not reach its destination, leading to service disruption. Redundant routing paths and resilient network design improve availability by ensuring that if one path fails, another can carry traffic. This concept ties back to the availability pillar of the CIA triad. On the exam, if a scenario describes network outages due to a single point of failure, improving routing redundancy may be part of the correct solution. Understanding routing as both a functional and security mechanism strengthens your reasoning across multiple domains. From a monitoring perspective, IP addressing and routing information are essential for analyzing network traffic. Logs often record source and destination IP addresses, ports, and protocols. By examining these details, security teams can identify unusual patterns, such as unexpected communication between segments or traffic from suspicious external addresses. Knowing how addresses map to networks helps you interpret these logs. For example, if internal-only systems suddenly receive traffic from external public IP addresses, that may indicate exposure or misconfiguration. On the exam, when evaluating network logs or communication scenarios, understanding addressing context helps you choose the most logical explanation. As you reinforce this material, practice summarizing the flow of traffic in your own words. A device creates data and assigns a destination IP address. The data is handed to the network stack, encapsulated, and sent to a gateway. Routers examine the destination network portion of the IP address and forward the packet along the best available path based on routing tables. Eventually, the packet reaches the destination network, where it is delivered to the specific host identified by the host portion of the address. This mental flow ties together addressing and routing in a way that supports security reasoning. When you can explain this clearly, you are ready to apply it to segmentation, exposure, and monitoring questions. To conclude, IP addressing provides logical identifiers that distinguish networks and hosts, while routing determines how packets travel between those networks. Public and private addresses influence exposure, and techniques like network address translation affect how internal systems communicate externally. Segmentation and subnetting rely on IP structure to create boundaries that limit attack paths and enforce access control. Routing decisions affect both security and availability, and understanding them helps you analyze logs and design resilient systems. If you carry one decision rule from this episode, let it be this. When evaluating network security, first identify how IP addresses define boundaries. Then consider how routing rules allow or restrict traffic across those boundaries.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.